is chemistry? Well, we can define it as the study of matter, but not just the study of matter, because that's what physics is. Chemistry can be defined as the study of matter, but at the atomic scale. Okay? So, physics is the study of matter, but it's the study of matter at all scales, all the way from subatomic particles and smaller, all the way to planets and bigger. It's the study of all of that. Chemistry is more focused. It's specific to the atomic scale. So atoms and molecules. That's what chemistry looks at. And one of the big things that chemistry looks at is the interactions between those atoms, which is what bonds are. Bonds are fundamental to how atoms interact because bonds are what create molecules. So, what are bonds? Well, there are three types of bonds. They are ionic bonds, covalent bonds, and metallic bonds. Now, each of these bonds has its own unique characteristics, but the one thing that all of them share is that they involve electrons. The process of making those bonds always involves electrons. Always, always, always. Let's look at ionic bonds. They are just a bond between two ions. Okay, one example would be NaCl. We can break it down into two parts, Na and then Cl. Those are the two parts. And then if we take a look at our periodic table of elements, we can see that Na is right here on the table, and it's got one valence electron. And chlorine, Cl, is right here. It's got 7 valence electrons. So Na, sodium, really wants to get rid of its one valence electron. That will give it a complete shell. Meanwhile, chlorine really wants to gain an extra valence electron to complete its shell. So what happens is these two elements, not these two elements, sodium gives up an electron to chlorine. It just hands it over to it. And that gives sodium a positive charge because it has one less electron. Meanwhile, chlorine has gained an extra electron, so it's got a negative charge. This creates a difference in charges between positive and negative, and as we know, opposites attract. So that's exactly what happens here. The positively charged sodium and the negatively charged chlorine are attracted to each other, and they stick together and make an ionic bond. That ionic bond makes up NaCl. And the important thing to remember here is that the charges will always balance out. You'll always have one positive charge and you'll always have one negative charge. And they'll always net to 0. The positive charge and the negative charge will always cancel out. Okay? So, that's how the bonds are created. But there's another really unique characteristic to each of these bonds, and that is nomenclature. Okay, so hang on, let me get a color. Here we go. That's nomenclature. So what is nomenclature? It's the same thing as naming system. It's just fancy words for saying naming system. So ionic bonds have their own specific nomenclature. Oh, I spelled nomenclature wrong. There we go. Ionic bonds have their own specific nomenclature. These bonds can be split into two parts, the positively charged cation and the negatively charged anion. Okay? And always, 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 in both formulas like NaCl and the name, you will have the cation come before the anion. That's always the order. And the cation, when you're turning it into a scientific name with words, it will always just be the straight name of the ion. So here, the name of the ion is sodium. So our first part is sodium. As for the anion, it's a little different. You take the name like before, but you make one modification. You change it to an IDE ending. So with NaCl, the anion is chlorine, Cl, so we write out chlorine, except we've got to have an IDE ending. So we can get rid of this INE and change it to an IDE. Now we have sodium chloride, right? That is the name of this compound. So NaCl and sodium chloride are interchangeable, all right? Now, let's try another example. This time, we'll go from the name to the scientific formula, okay? So let me move this down here. We'll use potassium oxide, okay? So let's split it into the two parts. We have potassium. That's going to be the cation because it's first. And then we have oxide. It'll be the anion. Now, if we look at the periodic table of elements, hang on, let me erase this stuff because it's distracting. Okay, if we look at the periodic table of elements, potassium is right here. Its symbol is K. So we'll write out a K. And then oxygen is right here. Its symbol is O. So we'll write out an O. Right? K plus O is what potassium oxide will be. Now, as we can see, potassium is in the first column, so it will have one valence electron, just like sodium. Meanwhile, oxygen is in the third to last column, so we can tell that it has 6 valence electrons. So that means that when potassium gives up its 1 valence electron, it will have a charge of plus, and the 1 is assumed since we're just putting a plus. Meanwhile, oxygen will gain 2 extra electrons, and it will get a charge of -2, or 2 minus. But as you can see, these don't balance out, right? If we just add these together, we will get KO, but it will have a net charge of -1. And as I said before, ionic bonds need to be balanced. They need to be stable. So how are we going to balance these charges out? Well, it's really simple actually. We just multiply the potassium by 2. Now this has a charge of +2, which cancels out this charge of -1. So we can say that potassium, we can put it all together and get K2O. So that's the same as potassium oxide. These two are interchangeable. Okay? And that concludes our lesson on ionic bonds.